Distinguished guests, ladies and gentlemen, welcome back. We hope you have enjoyed the refreshments and are ready for the next segment of the program. The next segment of our forum will delve deeper into the earlier discussed topics and feature presentations on climate change projections, multi-stakeholder climate resilience and adaptation, and the Global Early Warnings for All initiative. At the end of each presentation, guests are invited to participate in a brief Q&A session. You may ask your questions using the 3 microphones that are stationed across the room. We have them located at table 8, 11, and 21. Alternatively, you can submit your questions via the Pigeonhole app by scanning the QR code that will appear on the main screen during the presentation. However, because we are a room full of scientists and policymakers, we're all friends here, I strongly encourage active participation from the floor. Our first speaker, Dr. Faye Cruz, is the head of the Regional Climate Systems Laboratory at the Manila Observatory in the Philippines. She is currently the co-chair of the Coordinated Regional Climate Downscaling Experiment Southeast Asia, also known as CORDEX-SEA, and a member of the Asia-Pacific Scientific and Technology Advisory Group of UNDRR. I would now like to invite Dr. Cruz on stage to present on the need for high-resolution regional climate change projections for Southeast Asia. Dr. Cruz, please.
Honorable Minister Grace Fu, Professor Celeste Saulo, Professor Winston Chow, distinguished guests and speakers, ladies and gentlemen, good morning. Thank you for the opportunity today to give a short talk about the need for high-resolution regional climate projections, especially in Southeast Asia. As we know, and from our experience, Southeast Asia is a region at high climate risk. According to the recent World Risk Report in 2023, Southeast Asia ranks highest among the sub-regions in Asia and is the 4th highest region at risk globally. This is due to its high exposure to hazards, which include cyclones, coastal and riverine floodings, drought, and sea level rise, among others. This year, we have experienced the strong effects of extreme heat, in addition to the dry conditions due to the El Niño. These hazards have disproportionate and cascading impacts, with vulnerable communities and ecosystems being more affected. As in other parts of the world, records indicate increasing extreme weather events in Southeast Asia. Majority of these extreme events are due to floods and storms, which are also among the top causes of disaster events in the Philippines in the past 30 years. These extreme weather events have resulted in significant loss of lives and damages in our country, placing it a high risk to the impacts of climate change. Severe tropical storm Yagi has just left the Philippine area of responsibility, but not without taking lives and causing damage along the way. We can also see a general increasing trend in the Philippines and Thailand of people affected by these climate-related disasters based on the recent 2023 report of ASEAN. In a globally warming world, the IPCC reports that climate extremes will become more extreme. Although future warming in the region is projected to be slightly less than the global average, extreme heat events will become more intense and more frequent. Rainfall will generally increase in the northern parts of Southeast Asia, and summer rainfall is projected to be less in areas in the maritime continent. Extreme precipitation and flooding will become more frequent and more intensified. Sea level rise will continue to increase, contributing to shoreline retreat and coastal flooding, which is a concern for low-lying coastal communities. It is essential, therefore, to exert more effort in enhancing the climate and disaster resilience in Southeast Asia. Key to these efforts would be high-resolution regional climate projections. Information on projections of future temperature, rainfall, and other climate variables that result from increased atmospheric carbon dioxide and other greenhouse gases are obtained from global climate models. However, their typically low or coarse spatial resolutions can be problematic for areas like Southeast Asia with its complex topography. At low spatial resolutions, terrain and land use can be not well represented in the global models, hence their effects on local climate are not well resolved. Smaller islands can also be absent in these global climate models. So in the past decades, the regional climate modeling community has been working towards generating high-resolution climate data from these global climate model projections through different downscaling techniques. As we can see in this figure, showing the future change in rainfall, we can get more detailed information of which areas will be wetter or drier in the future. Initiatives such as the Coordinated Regional Climate Downscaling Experiment, or CORDEX, of the World Climate Research Program has helped advance regional climate research and has played a major role in downscaling global climate projections, which contributes to a more robust assessment of regional climate changes in the last AR6 report. For Southeast Asia, downscaling climate projections showed detailed information on the spatial patterns of the seasonal changes in rainfall, as well as in temperature and other climate variables. Climate extremes can also be better captured, and the changes in extremes are important to examine given the pronounced impacts on communities and ecosystems. For example, our analysis showed more frequent heavy rainfall days and dry spells in Southeast Asia under a 2-degree global warming level. And downscaling multiple models also provides information on the significance and robustness of these changes. For peninsular Malaysia, further downscaling to 5-kilometer resolution showed improved skills such as in rainfall. Comparison with observation data indicates reduced biases in seasonal mean rainfall in the 5-kilometer resolution run compared with the 25-kilometer run. We also see improvements in the skill in capturing the seasonal cycle of rainfall, which is important information, especially for sectors such as agriculture. Looking at future changes in extremes in peninsular Malaysia, for example, the model ensemble of the 5-kilometer runs indicates projected decrease in seasonal mean precipitation regardless of the emission scenario. Furthermore, consecutive dry and wet days are expected to increase and decrease respectively, which indicates a long dry spell in the future. At the same time, peninsular Malaysia is projected to also have fewer days with very heavy precipitation. However, the high-resolution climate information shows that some areas may have different signals. Understanding and characterizing future climate change is important because of the projected impacts. The latest IPCC report also shows increased severity of impacts across both natural and human systems, with regional differences. Here we see how future changes in temperature and humidity will increase heat stress, increasing risk of mortality. Downscaling provides information on spatial variability and hazards, which can be combined with information on exposure, vulnerability, and impacts to better assess risk. One example of such endeavor can be found in the SARCSIS website, and this is the Southeast Asia Regional Climate Change Information System, which hosts the output of the climate projections done by the CORDEX Southeast Asia Group. In Thailand, they used the high-resolution projection of climate hazards to combine with socioeconomic data to derive a risk score for the country. In this example, it shows the risk scores for the elderly to heat hazard per province. Another example here would be the risk to flood of human settlements. In this way, it is possible to identify the risk hotspots and, if needed, know which areas to prioritize and to provide targeted action, especially if resources are limited. High-resolution climate information helps in making evidence-based decisions on appropriate climate change adaptation and disaster risk reduction measures. The combination of contextualizing local climate information with local information on exposure, vulnerability, and adaptive capacity allows decision makers to understand the particular risk profile of a city in order to plan appropriately and, importantly, to avoid maladaptation. As we continue producing high-resolution climate projections, it is important to also note the value of establishing and maintaining long-term, dense network of observations, especially on the ground and on climate-vulnerable areas. Information from satellite data and reanalysis datasets are valuable and useful, but we note that there are still some limits and uncertainties, such as in high-elevation areas and islands, for example, where we can potentially see added value with a high-resolution model output, but it can be challenging to confirm this added value given the sparse observations in these areas at matching resolutions. High-resolution observation data allows an accurate assessment of model biases, which can inform potential areas for model improvement, or if there are processes that are still not yet well resolved in these models. In this example, we see that downscaling better captures the spatial pattern of rainfall, but we still see wet bias, especially in high elevations when compared with a gridded observation dataset. For one model, further downscaling can increase this model bias, but for another model, even at high resolutions, the wet bias is reduced. If we were to look at the model performance using station data, we see that daily rainfall distribution, particularly for rainfall below 100 millimeters, shows improved skill at higher spatial resolution. However, large wet biases can still be noted for extreme daily rainfall above 100 millimeters. A denser network of observation stations providing data at sub-hourly resolutions maintained over a long time period can also aid in monitoring and further understanding of extremes, such as these extreme rainfall events. Our recent analysis showed that the majority of the heavy hourly rainfall events in Metro Manila are caused by stratiform rainfall events, or these are the days with rainfall less than or equal to 10 millimeters, while the majority of the extreme hourly rainfall events are caused by convective events, which are rainfall above 10 millimeters per hour. A high-resolution observation network can also be used in our continued efforts in improving weather and climate models, and this also includes techniques such as statistical downscaling and machine learning. CORDEX Southeast Asia continues these climate downscaling efforts with ongoing work in downscaling the CMIP-6 GCM projections for the region, as well as further examining climate change in cities in Southeast Asia. Our group looks forward in building stronger collaboration in the region, such as with CCRS, and as well as with the impact sector and local decision makers as we share and support the vision of a weather-ready and climate-resilient ASEAN. Thank you very much.
Dr. Cruz, please remain on stage. We'll have our Q&A session for now. Do we have any questions from the audience? I've run quite shy this morning, but never mind. We'll have a question that came in online. So, Dr. Cruz, a question online came in. It says that, is sea level rise observed in the Philippine Islands already?
Hello. Yes, definitely.
All right. So
we are. It's one of the climate hazards that we're keeping an eye on, especially since we also have many coastal communities and small island communities.
Thank you, Dr. Cruz. If there are no further questions, may I now invite Dr. Cruz to take your seat. I would now like to introduce our next speaker, Dr. Aurel Moise. Dr. Moise is a Deputy Director of the Department of Climate Research at Singapore Centre of Climate Research. He was also part of the core research team for Singapore's third National Climate Change Study, the results of which were released earlier this year. May I now invite Dr. Moise on stage to share with us the findings from this study. and to share how climate change will impact Southeast Asia.
Thank you, Danielle. Thank you for the organisers to invite me to give this talk today. Distinguished guests, ladies and gentlemen, good morning. Happy to see so many people here from the region. This session is providing context to a lot of our discussions later throughout this forum. And I just want to say a big thank you to Faye from CORDEX Southeast Asia, highlighting the need and importance of having high-resolution climate change projections to inform local and regional decision-making. And I can't understate the important role of CORDEX and CORDEX Southeast Asia in providing this interface. So here I want to sort of build on this information by walking you through the journey that we did at the Centre for Climate Research Singapore in providing very high resolution, in fact the highest resolution downscaling information across Southeast Asia and even higher for Singapore over the last few years. We launched this project in the dataset earlier this year, and so today, aside from giving you some insights into what we actually did, I want to especially focus on the results across Southeast Asia and some of the impact topics. Let's recap. So we know from IPCC Working Group 2, can't believe this is already more than 2 years ago that these statements have been made. We're going to see more extreme weather events in the future, and it's affecting every corner of our planet. And especially across Southeast Asia, we will see an increase in heat waves, increase in heavy precipitation in many areas, as well as, importantly, some really significant sea level rise and coastal flooding, and Faye already mentioned some of this. I especially like one of the main outcomes and conclusions was that there is a rapidly narrowing window of opportunity to secure a sustainable and livable future. And we embarked on this study at CCRS to support local and regional decision making based on better and more high resolution information on how the climate is changing. So as I said, I'm going to show you just a few slides only on what we did in terms of the downscaling of the global models from the 6th assessment report, and then show some of the results both in terms of the projections and some of the impact studies we're already commenced. So here in Singapore, this was the third national climate change study, and that's why we call it V3, launched earlier this year, and it comes 9 years after the second national climate change study was launched, and they're all building on IPCC publications and scenarios and modeling runs of the latest generation of global climate models. If you're familiar with the IPCC assessment reports, you know there's 5 key future greenhouse gas scenarios. Of those 5, we picked in our study 3 of them. One that represents one of the Paris agreements at keeping global average surface temperature by the end of the century at 2 degrees or less, which is the SSP 126. Then a medium, middle of the road scenario, and then the highest risk fossil fuel development, taking the highway scenario SSP 585. And so similar to what Faye has shown before, is since the global climate models are far too coarse to provide relevant regional and local information, we downscaled these a selection of global models to 8 kilometers, so from about 150 down to 8 kilometers over one big domain, which is almost equivalent to CORDEX Southeast Asia domain, and then in a second step further down over the second domain, it actually goes down to 2 kilometer, and it was the 2 kilometer data where we provide a lot of information on early in January on how climate is changing specifically for Singapore. I just wanted to emphasize the need to engage stakeholders in the whole process before you start, but all throughout conducting the study, in making sure that what it is you produce is informed by stakeholder needs. So we engaged with local stakeholders before we started the study, but throughout the study, and then had two streams of work. One was the high-resolution downscaling I just mentioned over those two main. And the second one was on sea level rise projections. So as you probably know, the IPCC sea level rise projections are point-based because there are projections at locations of tide gauges that are existing and have long enough historical data records. And so we reran the IPCC methodology using the Singapore tide gauges that have long enough records, which end up to be 6. So we have information on sea level rise, but we also looked regionally. So I will show you some results from the region. This effort over the last 4 to 5 years was a national, whole-of-nation effort, because aside from the teams at CCRS working on this, we were very closely affiliated with Singapore's National Supercomputer Centre, since we spent years running our simulations there, and we also had a project with the group at the university that contributed to this project as well, and we, as I said before, constantly engaged with government agencies. So when we did launch earlier in the year in January, there was a lot of media attention created for this study, and probably one of the important, not surprising for us, but maybe surprising messages for others, is the strong change in projected changes in heat and heat stress. So I move on to the second part, where I will talk about some of the key findings. And just to note, these are selected. My talk is fairly short, so I can only pick and choose a few things that I want to highlight. But all the information is there for you to look at and explore at our portal. So as I said, we did look at regional sea level rise changes at specific tide gauges that you can see here. Now, just to make sure, this is by 2150, not 2100. That's why the numbers look a bit higher to what you're usually used to. A lot of those tide gauge sea level changes are within what the global average is, except at some locations where there's already been significant vertical land motion subsidence in the history, and those projections also project sea level rise to be higher than the global average. So a couple of examples here would be actually Bangkok and Manila, as Faye already is aware of in those projections. So the different numbers here are the 3 different scenarios, and as standard with same with IPCC, there is an average or a median and a range of projected changes, since we're running multiple models. If we look at temperature projections, I'm just going to pull out a figure here on the maximum daily temperature changes across Southeast Asia, and we see that there is an average change of in the high emission scenario that can reach above 5 degrees, which is a scary number considering where we are right now. You can see on the right-hand side the bars reaching above 5 degrees for the red high emission scenario. The map I just wanted to show you to highlight there are not necessarily hot spots, because they're much larger than just spots, but there are certain regions that are warming stronger than other regions into the future. And if we look at how many days are becoming hot, the key message is hot days will become the norm in the future. And just to emphasize this, is if we look at the 95th percentile of current hot days above the 95th percentile and evaluate the projected changes by country across Southeast Asia, this is an indication in the percentage increase per year on those hot days. And you can see that in the high emission scenario that there are several countries where more than half of the year will be a hot day. this will also then project itself in the change in heat waves, and I know there's several definitions for heat waves, and we're still also comparing some of those definitions. This one here is on the 95th percentile of daily maximum temperature for days and at this level or threshold and above. And you can see, so these figures show basically the change in the frequency, the duration and intensity of future heat waves across Southeast Asia, with significant changes in the data. So I won't be able to go into sort of high spatial details because my talk is not long enough. I thought I'd provide a bit more information on rainfall, and again, I'm just pulling out here extreme rainfall. One of the extreme rainfall metrics that we use is called RX5-day, which is the seasonal maximum daily rainfall change, 5 consecutive days rainfall. And that's why it's called RX5-day. And so there is the maps that show you that there is a spatial difference in how this extreme rainfall is changing. But the key with rainfall as well as extreme rainfall change is the story is all about what happens in the seasons. So if you just look at annual rainfall changes, there's nothing strong reveals itself. But if you look into the seasons, you will see that there's significant changes in the various monsoon and intermonsoon or dry seasons, especially around extreme rainfall change. On the other side, if you look at dry spells and dry spells characteristics, which some of the typical metrics that are used there are consecutive dry days. So the maximum length of those consecutive dry days, or the average length of the dry days, or how many days, so the average dry day count. These are sort of 3 different metrics. And if you look at these metrics, how these would change across Southeast Asia, and here we look at the November to April season, and where there's this clear separation between northern hemisphere dry and wet season. And what I'm showing here is the top row indicates the current 1 degree status of these metrics, whereas the 3 bottom figures show you the change at 4.5 degrees. So this is a certain warming level change in terms of the consecutive dry days, mean, maximum, and count. And again, sort of just overarching messages in terms of the increasing trends in all of these metrics. Something interesting is when we look at where we see historically, typically in the region, the biomass burning regions over some of the seasons, and we plot over this the consecutive dry day changes, and what we see here, there's actually quite a match, which means there's actually a potential higher risk in future fires and prolonged burning from these observed changes in what we see in our data set. So this was just walking through some of the key results that we see from our 8-kilometer data across Southeast Asia. And so just to highlight again, these are the 2 domains where we have 8 and 2-kilometer data sets for 3 scenarios, for 6 models till the end of the century, and this is a perfect data set to use for climate change impact studies in the region. So just to highlight some results. Similarly to what Singapore cares about is a sort of key climate change impact areas in terms of food security, biodiversity changes, energy changes in energy, and especially with the aim for net zero and renewable energies, the change in vector-borne diseases across the region, what is the impact of heat on human health. So these are key topics topics that Singapore cares about, but also the region. And so in Singapore, we already started supporting significantly the university projects in these areas. And some of them are focused in Singapore, but some of them are actually focused also on the region. As for example, with regard to food security, Singapore imports most of its food. So we need to understand how climate change is impacting source countries and supply line changes and everything around there. Which is a nice segue in one of the examples I wanted to mention here is as Thailand is, for example, one of the key source countries for rice imports to Singapore. The 8-kilometer data set allows you to go into the district level to understand what future passing of key temperature thresholds that impact rice planting, rice growth, and harvesting cycles. In this example, it's the wet season rice growing areas in Thailand, which produces over 80% of the rice in Thailand. And so we've looked, for example, at the planting season over 2 months, and what we find is in the northeast and central regions by the end of the century, there is 2/3 or more by the end of the century crossing these key temperature thresholds and impacting potentially significantly on rice yields in Thailand. So we are continuing this for Vietnam and Indonesia at the moment, and we'll write this up beyond just a report that's shown here. Another example, and again I'm just sort of providing examples, is we're looking at what we call dengue climate suitability. So this is just what are the key climate parameters that would allow dengue mosquitoes, the 2 key species, to thrive in the region, and do an analysis. This is work that we do together with a group at NUS. And the 2 key dengue-bearing mosquitoes, Aedes aegypti and Aedes albopictus, are being simulated in terms of the baseline period suitability, and then we can see how this can expand once we hit the future high emission scenario across the region. The next example I want to mention just is heat stress, and I'm not going to go into too much detail because this is actually going to be part of Sandeep's talk later today, where he'll show high-resolution WBGT information at 8 kilometre for the whole of Southeast Asia, which has never been seen like this before for this region. I just wanted to emphasize Singapore has a network of WBGT sensors, and that is expanding, and so WBGT is the government advised and accepted measure for heat stress, but it's not a trivial measure in terms of putting it together once you get the simulations, because there's 4 different variables involved, and you need to understand how to correctly simulate WBGT. And so we provided this we did this for Singapore, and we provided all the information when we launched earlier this year, and we showed that potentially over 300 days per year could be red flag high heat stress days by the end of this century. These figures on the right-hand side are examples, apart from Singapore, also from the Philippines, in where we see the change over the Philippines in terms of WBGT, and Sandeep will later show the maps. To me, heat stress will emerge as one of the key topics over the coming years, especially around urban science and climate change, and Faye already mentioned the urban project that's going on within CORDEX Southeast Asia, looking at Southeast Asian megacities. We're also running a very high resolution urban system forced by our data to look at Singapore urban heat island effects and heat stress. So coming to the end of my talk, I just wanted to highlight that we produced a lot of information through this project, which is captured in two reports. We have a stakeholder and a science report, sort of mirroring on typically what happens in IPCC. But we also have a data visualization portal with over 4,000 images where you can explore our results. At the moment, all of this is visual. You can access all the reports, the brochures, the videos on the portal. What you can't access is data, because that is currently, the data sharing is currently being built, the portal. So we accept at the moment email requests for data, which we will follow up and honor, but sometime early next year we'll have an automated data sharing mechanism for those who want to use our data to do project. The portal is also mobile friendly, so you can just scan the QR code on the top and start exploring our site. And so with this, I want to thank you for listening, and I'm open to questions. Thanks.
Thank you, Dr. Moise. We'll be taking questions from the floor now. Would anyone like to ask some questions? We have 3 microphones across the room. Feel free to run up there with great enthusiasm. All right. In that case, we also have questions online, and we'll start with the first question. So the first question that we have for you, Dr. Aurel, is, should we look beyond climatic variables for heat waves, and beyond heat waves to include hot days and warm periods?
Yes, so can you repeat the first one again? Should we look beyond climate variables?
Should we look beyond climatic variables for heat waves, health impacts, and beyond heat waves to include hot days and warm periods? So we also have the questions on the screen behind you. It might be easier to have a quick check there.
So the first part of this question to me is a no-brainer. If you look at heat and human health, you do need to include other variables apart from the climate variables. And we're actually working more closely with Jason, who's on the human health heat side, and we do want to bring those closer together, especially in Singapore. Singapore is unusual because we are right at the equator. It's always hot and humid. We have very high nighttime minimum temperatures, so that there's not a lot of relief in Singapore.
Thank you, Dr. Moise. The next question that we have is, will Singapore's current definition of heat waves, which is the daily maximum temperature of at least 35 degrees for at least 3 consecutive days, will it be updated in the face of worsening heat?
So, so from my standpoint, I don't think there's a connection between what the definition is and when the heat is worsening. There's no reason to lift the level of the threshold just because it gets hotter, because the threshold definition comes from a different standpoint. The threshold definition comes from the human heat angle in terms of what we think is we are adapted to or what we can cope with. And if it gets hotter, raising the threshold is in my opinion not the way to go. But of course there's a lot of different opinions that go into this in terms of what will actually be happening in the future.
Thank you. And now our final question. In the V3 dataset, can the urban climate effect be resolved?
Simple answer is no, and that's why we actually just finished 100-meter climate change runs for Singapore, which are absolutely unprecedented. And so we took our 2-kilometer climate change data and forced a 100-meter model to understand the local warming on top of the global warming, and as well as one of the key mitigation efforts that Singapore is planning, which is 1 million trees. So hopefully by the end of the year we'll have a paper out that describes this.
Thank you, Dr. Moise. If there are no further questions, Dr. Moise, may I invite you now down to take your seat. Thank you so much. Our next speaker, Ms. Juli Trtanj, will be joining us virtually today from the US. Ms. Juli Trtanj is the Director for NOAA's Climate and Health Program and the Executive Director of the National Integrated Heat Health Information System, NIHIS. An expert in the climate and health field, Mr. Trtanj leads the NIHIS and Extreme Heat Interagency Working Group with the National Weather Service, bringing together numerous federal agencies. Mrs. Trtanj has also contributed to the 4th assessment report of the IPCC, which was collectively awarded the Nobel Peace Prize in 2007. Today, we are honored to have her present on the importance of a multi-stakeholder approach towards climate resilience and adaptation, and why we must focus on putting climate services into practice. For the questions today, for this presentation, we will only be addressing the questions that are on the floor, so there won't be a pigeonhole QR code for her presentation, all right? So we'll let you know when it's time for you to ask the questions. Thank you very much.
Thank you very much. It's Ms. Fu and Professor Salo and distinguished guests, fellow scientists. It's a real honor to be able to address you today. Thank you for your time, and good morning. It's late here, but morning for you, so it's been fun to watch. I'm honored to be able to speak with you about something that may seem very obvious, but we still have a little bit of work to do in terms of really addressing multiple stakeholders as we build out climate services. Next slide, please. So we've already heard this morning that, I'm going to set my timer here. We heard this morning a lot about some of the impacts, so I'm not going to go into that so much, but just suffice it to say that whether it's drought, floods, hurricanes, typhoons, cyclones, heat waves, we heard a lot about heat waves, they're all increasing, they are complex, and they have significant impacts on our society, our lives, and our livelihoods. And as Met Services and those who support climate services around the world, it's our job to help do a better job, an even better job, continually to improve how we deliver those services. Next slide, please. So we have already heard that we have a lot of these pieces in place. The Global Framework for Climate Services is not new. Next slide, please. It actually has a health focus, it's drought. It's really trying to get at societal norms, societal impacts, and we've been working at this for quite some time and reinvigorating it more recently. It is supported by the Climate Services Information System. So this information system is going to be a recurring theme because it is a very different way of thinking about how we approach stakeholders, all right? So we've got this Global Framework for Climate Services infrastructure already in place. Next slide, please. We also have the Climate Services Information System also in place, the operational core of how we deliver climate services. And if you'll see on the outside of that circle, that right underneath the larger green is user engagement. It permeates all the way through to the middle about building capacity. So how we engage with stakeholders and how we actually ask the questions and define the problems we're actually trying to solve is really critical for how successful we'll be in the development of climate services that do give us early warning, longer lead times, use the science and the capacity we have to predict to really save lives and protect lives, livelihood, and ecosystems. Next slide, please. One more, please. And again, we have a structure here, and if you add, these are, any one of these would be an entire talk, and we're just basically looking at the structure with which we as Met Services and the WMO have already in place. And if you hit one more, we have our regional climate centers and our regional climate forums. So we have a whole panoply of institutional infrastructure by which we can deliver services. Now, is it perfect? Do we have issues? Yes, absolutely. But the structure is there, and we're doing a pretty good job of doing this. You've heard this throughout the morning already. Next slide, please. We're looking at all of the impacts on the right-hand side, but the question becomes this: how do we actually make sure that this isn't a one-off? And we have some cases of where this has been successful, and I'm going to talk to them in just a little bit. But there's still this little, what happens here, a miracle occurs. And that miracle occurs when climate services are successful, it's because we have been not just doing the great science that you do and building the services and delivery, the information, but it's because we have engaged our stakeholders in a deep and meaningful way. It's not just having them show up at a meeting and throwing something at them or talking to them once a year or once a quarter. It's understanding in a very deep way what problem you're trying to solve, who thinks it's important and why they think it's important, what's on the line for them in using our information to make their decision. What do they need? When do they need it? What are the institutional roles? What are the roles of the humans involved? Somebody's going to make this decision, and if they're wrong, there's going to be consequences, and if they're right, there's going to be good consequences. Understanding that is a really critical piece, and that's how we actually move forward together in a very different way than just engaging stakeholders in a workshop or something. Those are fine too, but that's not the deep and meaningful kind of partnership that we really need to serve society moving forward. Next slide, please. So this is one of my favorite slides. I hope you don't mind, a little levity in the morning. But one of the biggest problems with communication is the illusion that it has taken place. This is one of my favorite quotes from George Bernard Shaw. Even in this room, I'm talking about stakeholders, we're talking about seasonal forecasts, we're talking about impacts. Even among scientists who are in the field, there are probably different perceptions. And when you talk about dealing with a water resource manager or a public health professional or somebody dealing with drought or famine, the perception and their mental framework by which they are approaching the problem is very different. So this whole issue of communication is a little bit of missing each other sometimes. Not always. We have some good examples of where it's working, but we want more of those. Next slide, please. So thank you very much. So the point of this one is really we're looking at cascading and compounding hazards. This is research that we need to do, but it's research that we need to do to be able to address compound hazards. And what are those storylines? To be able to tell the story and address the weather to climate continuum, to deal with transboundary, transdisciplinary entrepreneurs and boundary organizations and boundary people within our organizations. We need to also understand a little bit more about what collaborative learning and collaborative design is, not just co-production, meaning develop a product together and you're done. There's a deeper meaning behind that. And basically, there is already recognition that we need these integrated information systems across several of our platforms with which many of us work on a regular basis. Next slide, please. So what is an integrated information system? It looks pretty straightforward, but it's actually grounded in policy science theory. Harold Laswell, a whole lineage of thought gone into this in the policy sciences. And if you look at the middle circle there, it's really the structure, the part in blue, agile, informed policies, integrated, trusted relationships, system management approach. These are the characteristics of an integrated information system. They help improve decision-making and maintain service delivery, but it starts at the top with knowledge transfer. This is the shared learning, the knowing your partner, knowing the problem, understanding the risks that they're facing and taking a decision based on the information you're providing to them. Co-development, monitoring and prediction are bread and butter. Observations fit in there too, of course. Planning, preparedness, research and assessment. All of these are components of the puzzle there. So if you go one slide forward, please. Other way, there we go, right there, please. These are the characteristics of an integrated information system. And I want to pause here because these are the essence of establishing legitimacy, authority that leads to action. So these trusted relationships have got to be more than just one-off. They have to be long-lasting. We have to be able to create a culture within our community and within our meteorological services and within WMO, which we're already doing, to really sustain and engage the decision makers. And that's a whole can of worms in decision makers. We're talking state, local, national, individuals. There are lots of different types of decision makers, but we have to really value and legitimize the engagement with those partners in a long, sustained kind of dialogue. And that's what integrated information systems do. They start with that to begin with. understand your partner, understand the problems they're trying to solve, what their decision context is, and then move forward together. It's a systems approach. It's agile and flexible. So you can respond to more quickly to some of the issues that are coming up as needed. And obviously it's going to inform policy and investments, private sector, government investments, all kinds of investments in observation systems and forecast products and wet bulb globe systems and sensors, which are not inexpensive. And again, integrating throughout the learning from all the phases so that there's a continual evaluation, which I think might go without saying, but that's a really critical part. Next slide, please. So I'm going to talk now just about a few of some of the examples. A couple are drawn from our experience in the United States, and some are drawn from many of you, probably even in the room. So the first one I'm going to talk about, an integrated information system, is the National Integrated Drought Information System. And I know we have the Integrated Drought Management Program at WMO, and there are similarities there because the NIDIS program helped inform the international program. So they are, of course, understanding the decision context, really working to engage the end users, but they're no longer the end users. They're just a part of the team. They are a part of the package deal, and they're with you from the beginning. And that helps us improve the observations. It helps us produce better and more targeted solutions and better focus the research needs that we need to fund and do and execute to be able to improve the product and the services that we're delivering. We co-develop them. We do support planning and response, and then obviously build capacity. Next slide. So those are the core components of how an integrated information system functions. There is a lot of convening, delivering information through drought.gov, heat.gov. I actually lead the heat one, and advancing research into actions all the way from the downscaled climate information that you just produced in Singapore. That's going to be incredibly useful for heat. I'm super excited to get my hands into that. I heard about it when I was just there a month or so ago. So that kind of advance we really do need to continue to do, but it's justified because we're understanding that that's what our users actually need from us. And then we're working with them. So it's not something that we're just putting out on a website that may or may not be used. We already know it's needed and it's ready. They're ready to use it. Next slide, please. So when we talk about multi-stakeholders, I'm not going to go through all of this, but this is what it looks like. It isn't really clean. It's not really linear. It's kind of messy. It can be really fun, but it isn't necessarily linear. And that's basically what I want to say. There's government agencies, there's the non-governmental organizations, international organizations, private sector, academia, tribal communities, indigenous knowledge. There is a panoply of actors in this space, and engaging that community is what we need to do in terms of changing the culture of how we work in this space to be more effective communicators and deliverers of climate services that really do make a difference for society. Next slide. That's the theoretical one. This is what it looks like in person. This is just an example of a workshop, but these are the different types of players that come. So we need to get used to doing this on a regular basis and sustaining it. I think at some of the climate forums and climate outlook forums, the old ones used to have some of these partners there. We really have to be sustaining this dialogue and this partnership in a new and much more robust way. Next slide, please. So I'm going to switch gears a little bit to heat. That's what I do most of my day job. And you're going to hear a little bit more about heat from John Nairn and Jason Lee a little bit later in the day or tomorrow. But we all know that heat is on the rise, and the way we feel heat will change and is changing, both the intensity, duration, nighttime temperatures, the whole bit. Next slide, please. So knowing that we were anticipating increased changes in heat, not just heat waves, but also just ambient temperatures and the changes in those. Back in 2015, NOAA and the U.S. National Oceanic and Atmospheric Administration and our Centers for Disease Control launched the National Integrated Heat Health Information System based on the same principle. So the climate weather people and the health people, we launched this under an interagency group and had several agencies to begin with right at the table, 8 or 9 of them. It was a coordinated federal approach, multi-agency, multidisciplinary, across time scales. This isn't just managing a heat wave, this is managing heat, including heat waves. And it's about building awareness, evidence, and capacity. And also in this, so we've been around since 2015, and this administration has been very supportive of heat and created a working group, which we also support and have been able to move forward pretty quickly because we were already working in the space. So that's called the National Integrated Heat Health Information System, NIHIS. And next slide, please. There are 30 agencies and departments involved now, totally committed. We have just produced the first ever national heat strategy, soup to nuts, total timescales, 30 agencies. This is our vision, which is basically a thriving heat resilient nation. Some of us wanted a thriving heat resilient world, but some of our leadership thought that was, too much to get. It was our goal, right? That's what we'd really like. So, and then our mission, we're actually up to 30 agencies now, basically understanding what people need, developing science-based solutions, and improving the use of that information to improve decisions. We do have a One Health approach in this heat world, and so that also expands the stakeholders that are involved in the discussions about heat in the United States. Next slide, please. This is just, I won't go into this too much, but just to say that this is basically structured along the lines of an integrated information system. What does society need? What science do we have that supports it? What do we need to develop? What are the solutions? And what is the infrastructure that supports that? The infrastructure is things like, it's things like legislation, it's things like funding, it's things like training and capacity building, the workforce, that sort of thing. If you go to the next slide, again, it's going to be a little bit of a messy slide, but these are the types of organizations that are working together on a regular basis now to address heat in the United States. It's the research and data providers, it's the policy and regulation folks, it's those who have funding that support low-income heating assistance, it's those who do climate resilience, regrowth and rebuilding, and a lot of technical guidance and support from some of our agencies. And we're all at the table on a regular basis, bi-weekly, sometimes more frequently, certainly our agency heads quarterly. So this is an ongoing active effort with all of the agencies really very much involved. And we've been working on this since 2015. So my point is it doesn't happen overnight to build these partnerships. Next slide, please. I thought it would be useful to see just to showcase a few of the activities that have come out of this partnership. HHS is our Health and Human Services, and they put together a heat and health index based on the NOAA weather data. It basically is a vulnerability map based on your heat index of where, and some social vulnerability information that where we have higher risk of those susceptible to heat. We have everything from a photo competition to really try and articulate and visualize what worker heat looks like. We have some bulletins that are coming out of our Health and Human Services. Our public health side is taking the weather and climate information and producing it and putting it out to the public health side of things. Next slide. And a couple of things that NOAA is doing, I will focus mostly on the urban heat island mapping, because that is a very good way of engaging your local communities. And it doesn't have to be just heat, but for us, we've been focusing on heat, and that is a way of soliciting volunteers, and people actually do a mapping of their own community. It empowers them to understand their own vulnerability and risk and be involved in developing their own solutions. We do a lot of social media campaigns. Again, that's a huge partnership effort, including the non-governmental organizations and states and tribes and territories. The other tools that we have developed as a result of the ongoing partnership that we have with our regional and our local communities. We have done 4 or 5 pilots in specific areas, and they have led us to these tabletop exercises and these guidance documents that we have given back out to our communities to help them. Next slide. I just want to put this in because we're very excited. We have 2 centers of excellence that we've just announced. Well, not just announced, they've been out for a little while now, but one is on monitoring and observations for heat, and the other one is more on the policy and assessment side. So that is yet another way that we'll be sustaining our engagement with our partners. Next slide, please. Okay, so I want to turn a little bit to some work we've done with WMO and WHO, the World Health Organization. I was honored to help co-chair the WMO-WHO joint task force, or the joint activity on climate services for health. And WHO clearly has stated that climate change is one of the biggest threats to human health. So from the WMO perspective, that's a long-standing partnership. There's been an MOU with the World Health Organization for quite some time, and we are diving deeper into that. Next slide, please. After 4 years, the WMO Congress approved a resolution for climate services for health. This right here is basically the structure of it, and the things that you see on the left are urban climate. That is where a lot of the health work has come in our global heat health information system. The priorities on the left are where we would like to start focusing and are starting to focus. And the ones on the right are more of the infrastructure kinds of pieces. And then the middle is, again, the scale issue, working at multiple scales. Next slide, please. The reason I put this up is that the State of Climate report was focused on health this last year, and it was great to have the focus, but also a little bit unnerving to find that only 31% of the Met services have the capacity to deliver tailored information for the health sector. While 74% of us say we're delivering data to them, only 23% of the ministries of health are actually using it in any of their health surveillance or decision-making systems. So we have a bit of ways to go there on the health side of things. Next slide, please. And let's go and skip over that one. Next one. Part of what we did in this infrastructure is knowing that we have the machinery of WMO already working for us, and there are focal points on climate services, climate service integration systems. We actually established and asked for focal points for health. We have about 100 of them. We are beginning to cultivate that cohort, and we really would like to make sure that the Met services around the world, if you don't have people focused on health, that you begin to do that. And if you do, you empower them and support them to work with their partners, because it does take that partnership approach. Next slide, please. You'll hear a little bit more about the Global Heat Health Information Network. That is actually codified now under the World Meteorological Organization. It is a big global network of practitioners and scientists and policymakers addressing heat risk globally, but it is led now out of WHO and WMO, but in the joint office that's housed at WMO. The Global Heat Health Information Network is quite a broad focus area, and we've done a lot of very interesting things in terms of addressing upcoming issues like heat wave naming and things like that, or heat and COVID. So it's very, again, responsive and nimble and user-driven. Next slide, please. You're going to hear, I'm sure, from Dr. Jason Lee about the new node that has been launched for GIN in Southeast Asia. So I'm not going to go into that, but just you're in very good shape there. Next slide, please. So this is an example. I don't want to make it sound like we aren't doing this well in some places. We are. We've got a really great example in the Caribbean. I'm sure there are examples in other places of where we have engaged users over a period of time and are producing amazing and actionable information. Next slide, please. One more. And given that we are all looking at climate services, one more slide, please. The benefits of them greatly outweigh the cost, but the capacity to deliver is really limited and uneven. And this gets back to why I was talking about stakeholder engagement. That is the critical piece. We have a lot of information, we've got a lot of knowledge, and yeah, there's a lot we need to do to understand and improve the quality and the resolution of the information we're providing, but we really have to change our culture. If you go one more slide, please, to really empower our Met services to engage with our user communities, and don't think of them as users, think of them as one. And it might not be the forecaster, that might not be the right person, but we have to really give ourselves and the Met side of things the space and the authority and the mandate to work with our user communities. For me, the health community is a great example. It takes cultivating, it takes time to understand what people are talking about and really figure out how to work together well. And we don't want them going off and doing it without us, which is also very likely to happen if we don't step up our game. So this is my final slide, just giving some ideas about how to get started, where you are in the process. It doesn't have to be a formal MOU. It doesn't have to be a 30 agency agreement. It can be a cup of coffee with somebody that says, hey, you know what? I'd like to understand what you do better. How can we help you more? And it can go from there. So I just want to make the point that it can engage at different levels at any point in time. And there can be very positive outcomes without having a big formal MOU. And with that, I will just say, last slide, please. I will say thank you very much for the time. And I hope that you have some questions for me. And if I have imparted nothing else, I hope that you will understand the need to engage stakeholders in a slightly different way and the importance of empowering your staff, your people, your Met services in a way that they can sustain that engagement, or maybe change the culture a little bit and hire some different kinds of folks or work with people in a different way. But we are close and we have the structure. We just need a little bit of a stronger push to engage in a sustained way. And this is my favorite quote from Albert Einstein about thinking the way that we got us here will get us where we need to go. So thank you very much for your time, and I'd be happy if anybody has a question.
Thank you, Dr. Trtanj. Do we have any questions from the floor? All right. Hi there, Thea. Let's have your question.
Thank you for the very inspiring talk to encourage us to all co-develop, co-produce together. We had an informal survey, and a lot of us here are meteorologists or work in meteorology, so we're used to looking at skill scores and trying to improve our predictions, our weather forecasts. Is there something we can similarly do with engaging with stakeholders in that, a way to track our progress?
That's a really good question, and I love it that you brought that up. So you can track progress with your stakeholders in part by the actual uptake of the information. So you first of all, not everybody needs to be the person that goes talks to the drought manager or the water resource manager or the public health person. So it doesn't have to be everybody's skill set, but you can track it by what information they're using and what decisions they're taking. And when you're working with them, you should keep score a little bit, not yes and no, but like, what are they doing and is it working? And is it working for them? You know, if somebody's going to have to make a decision about when to release water for a dam and it's going to, flood something else, these are trade-off decisions that need to be made, or to spray for mosquitoes, or to do a dengue campaign, or to do a bed net program. They all have costs. And if somebody's wrong, something's going to happen if they get it wrong. And we have to stand by them when that happens too, and be able to be clear about the skill with which we are producing the forecast, what we feel confident in. I will say we should not let perfection be the enemy of good and useful. I will say during COVID, there was a lot of controversy over whether the environmental drivers for COVID were valid, whether we could use them in predicting. And in the US, for instance, our military had a forecast, and they said, this is not great, we don't really understand it, but it was a decision advantage for them. It was what we knew, and we were just really clear that we didn't know that much. So I think you can gauge by what decisions are made by your partners. I mean, that's the best gauge. It's not really a Menti poll, although those are kind of fun. You can probably do those too.
Thank you very much.
Thank you for the question.
Thank you, Dr. Trtanj. Do we have any more questions? We do have the standing microphones in the room that you could approach to ask your question.
Thanks very much, Julie. 2 questions. One, given the challenges involved in adequately dealing with heat stress at the population level, Do you have any comments on any adverse incentives for governments to recognize the dangers of heat stress? Secondly, I did a quick search just now. There are certain parts of the US that define heat waves as, I'll use Celsius because most of the world uses that, 32.2 Celsius over at least 2 days. And I recognize that varies across the US. We heard a different definition just now, and that varies across the region. But what is the physiological basis for determining the level of heat stress in the human body? And does the NHHI intend to put forth a global standard, given that, all humans are humans, regardless of passports?
Yes. That was a lot. Good questions, though. So let me answer the last one first. So there isn't, even in the US, we have a scaled, we're not trying to define a heat wave that will be generalizable, and we're not trying to set a global standard for heat waves. NIHS is not doing that at all. We're actually, in the US, have a couple of tools that are scaled on like a 95th percentile from your normal. And we have the ability to go down to recently a census tract level. So it allows the user to basically get their own anomaly that is more relevant for them. Now, when you're talking about the physiological norms by which people respond, you have people in that room who will know far better than I and can have a conversation about biophysiology. So I would actually suggest you talk to them, but they are also the heat that we developed a new tool called Heat Risk, which is actually based on human health data and human health anomalies. So we did the analysis, and the tool is based on that. But it's still a percentage from the norm of or an anomalous heat day. So anomalous temperature. So I think, and no, we're not, NIHS is not going for a global standard of any sort. So the global standard would be engaging users so that you actually develop a product that is really targeted for what somebody actually needs. Not a global standard that might not be relevant for different physiologies and different levels of humidity and all kinds of variants. The first question was about disincentives, I believe, for policies for heat, and there are a lot of those. That almost is it can be a community-specific thing. But I will say at the national level, we are looking at making sure things like our heating assistance programs are available for cooling in the summer. There are also, I'm not sure I'm getting at quite what you were asking, but the disincentives are clearly there when you talk about, if air conditioning is what you're looking for, not everybody can have air conditioning and has greenhouse gas implications. So that is definitely not the solution that we want to go to. But from a public health perspective, for keeping people from dying from a heat wave, an air conditioning unit of some sort or a swamp cooler or something is a good solution. So yeah, those are really tough trade-offs, and they are very real. So those are, one of the things about heat is that it is so local that those decisions are usually made at a very community level. And so what we're trying, community organization, even a state level. So what we're trying to do is systematically encourage everybody to have a heat plan, a heat strategy. It doesn't have to be a separate heat action plan. It can be a part of an all hazard plan, but we are encouraging that. So and we'd love to see if we could do that for everybody in the globe, that would be fantastic. So I will say we are trying to do that, at least in the US. And I'm not sure if I totally got the rest of that question. I hope I at least got part of it.
Our final speaker for this segment will be Mr. Ben Churchill, Director of the WMO Regional Office for Asia and the Southwest Pacific. Hosted by Singapore, the WMO Regional Office for Asia and the Southwest Pacific serves 59 WMO members, the highest of the WMO regional offices. As director, Mr. Churchill ensures that the office provides, facilitates, and coordinates technical advice and support for the WMO under the office's purview, and that the diverse needs and priorities of its members are accounted for. I would now like to invite Mr. Ben Churchill on stage. Thank you. While we are waiting, I understand that some of the audience had questions for our earlier speaker. So if some of you still have access to the Pigeonhole app, yes, I saw a very enthusiastic hand raise over there. If some of you still have access to the Pigeonhole app, do feel free to submit your questions anyway, and we'll find a way to make sure that those questions do reach Dr. Trtanj as well. All right, all your questions are important, and it's not often we have such an opportunity to engage with such speakers too. All right, so please do that while we are waiting in the meantime.
Thank you so much for your patience as we sorted out the technical issues, and thank you for the support rendered. Secretary General of WMO, permanent representatives with WMO, distinguished delegates, colleagues, ladies and gentlemen, a very good afternoon. Thank you all for being here and for enabling this opportunity for me to share with you an overview of the Early Warnings for All initiative and the opportunities it presents in the Asia-Pacific region, but more specifically for the ASEAN member states. Allow me to start by setting the context and building your understanding of why this initiative is so important for all of us, now and into the future. That's easier. So unfortunately, the world does continue to warm at an alarming rate. And the last 13 months, as we've heard, have been the hottest on record. The most recent State of Global Climate report released in March this year confirmed 2023 as the hottest year on record by a clear margin. And 2024 is on track to be hotter again. We have also heard that on 22nd of July this year, the hottest day on record was broken, when the average global daily temperature peaked at 17.14 degrees Celsius. Extreme weather events are becoming more frequent and intense. Complex, compound, and cascading disasters are touching everyone and are set to increase by 40% before 2030. And extreme temperature events will triple. The World Economic Forum Global Risks Report, which is produced every year, is a collection of thinking and ideas from world leaders and economists on what is further down the track, 2 years advance, 10 years in advance. And we can see from this slide that in 2 years' time, extreme weather events will be ranked second, and the green bars represent environmental hazards and issues and risks. In 10 years' time, the green bars rise all the way to the top, and we have extreme weather events predicted to become the most critical risk for the globe. which will result in changes to Earth systems, biodiversity loss, ecosystem collapse, and natural resource shortages. So this is something that we need to pay very close attention to. The world's cryosphere, as we know, is impacted by rising global temperatures. And we are seeing melting glaciers and shrinking ice sheets, which is contributing more water to the atmosphere and leading to intense rainfall, floods, landslides, and sea level rise is putting increasing pressure on coastal communities and also low-lying islands in the Pacific and also in Southeast Asia. And this is very relevant to this region because it is not just a symptom of climate change, but it is actually one of the main causes of many related problems for society. And this is why WMO and its partners are paying particular attention to the cryosphere. And this is one of the key focus points for WMO as decided by its members. So we understand after a global review of the world's capacity for early warning systems that only half of the world's countries report having sufficient capacity to alert citizens about impending hazardous weather and climate conditions. The good news is that early warning systems cover approximately 65% of the world's population, but mostly in OECD countries. The not so good news is that in the least developed countries and small island developing states, the coverage is far less, and in fact less than 50%. And in small island developing states specifically, it's about 40%. So there is clear that there is much work to be done to close the early warnings gap. And this is why the Early Warnings Fall initiative is so important, as it seeks to ensure that all people on the planet are covered by people-centred, inclusive, multi-hazard early warning systems by the end of 2027. And I won't go into too much detail because I'm a bit short on time because I realise I stand between you and a nice lunch. But just to run through the 4 pillars again very quickly and who is responsible for those. So on the top left we have disaster risk knowledge, which is led by the United Nations Office, Disaster Risk Reduction. On the right-hand side, which is where we're spending a lot of our attention, is on detection, monitoring, analysis and forecasting, and this pillar is led by WMO. In the bottom right-hand corner we have warning, dissemination and communication, which is led by the UN International Telecommunications Union. And on the bottom left, community preparedness and response is led by the International Federation for Red Cross and Red Crescent Societies. So the areas for focus under this initiative in 2024, in very brief terms, are accelerated implementation, providing coordinated support and technical assistance to bridge the gaps that I mentioned earlier, expanding the outreach, going beyond the 30 initial focus countries, and including other countries that are interested and prepared and ready to join the initiative, and also importantly, unlocking funding for sustainable early warning systems, strategically accessing and leveraging funding to ensure that this action contributes to achievement of the Early Warnings for All goals. And I won't deliberate too much on this slide, but this is a bit more of a deeper dive into the role of WMO and the way that it leads Pillar 2 in a very much a partnership approach. And only a third of the WMO members report having multi-hazard monitoring and forecasting systems, so we do need to work particularly hard to address these gaps. And one of the things that we would like to talk about over the next few days is how we focus on this in the ASEAN context, recognising that we have all of our ASEAN member states and their national meteorological hydrological services here at this forum. This is a good opportunity for us to explore how we can collaborate with you to make this a success in this region. And I might just skip over this slide other than to say that this really encapsulates the value cycle of the climate, weather and water approach. And as was mentioned by our Secretary General earlier this morning, that we put a lot of effort and investment into the first part of this cycle, which is observation, but we need to do more. Because without these critical observations, we cannot produce the accurate and timely forecasts that community and governments expect from us. And the other point I would like to make, and just to reiterate what was said earlier, is that it doesn't matter how good your forecast is, if it doesn't reach the intended user, and if no action or the wrong action is taken, then we have failed. And thirdly to that, we need to understand how the user is using the information. And so we heard a nice question that Julie responded to in terms of tapping into how the users are using this information, so we can make this a true cycle and feed that back in to improve the work that we do. Now I just want to zoom in a little bit on the regional context in Asia Pacific, and to let you know a little bit about what WMO and its partners are doing in the context of implementing the Early Warnings for All initiative in the Asia Pacific region. So as I mentioned before, WMO is working with partners, UNDRR, ITU and AFRC, but also with strong support from another UN agency, which is the Economic Social Commission for Asia Pacific, ESCAP, who are here with us today, I'm very pleased to say, to really lead on the initiative and coordinate implementation in the region. Initially for 11 countries across the Asia Pacific, but in the future we would like to see that number increase. So the level of commitment is increasing, the awareness is there, but we do need to work harder to deliver on this. I would like to acknowledge ESCAP for providing critical support, particularly on the transboundary hazards. As was mentioned, climate and weather do not respect political geographical boundaries. And so this real cooperative approach is essential for success. And also we have a number of initiatives that are underway, such as the CRUISE initiative and also the Systematic Observation Financing Facility, which is enabling particular countries to improve their capability. We also understand that in this region, Cambodia and Laos have taken some very bold steps forward to develop their national roadmaps in consultation with a broad range of stakeholders in their countries to engage with the donors and to develop implementation plans. And we would like to learn from their experience and encourage them to share that with other countries so that they can consider joining the initiative. And as we mentioned, our Secretary General was in the Pacific just recently in Tonga and also in Fiji. The Pacific Islands are implementing early warnings for all through a particular regional program, and we would like to encourage ASEAN to consider something similar in this context. So I will fly through some slides because I've been given a warning that 5 minutes is approaching, but some of the other tools that we're developing are the State of Climate reports to support and provide information to inform the early warnings for all. State of Climate in Asia was released in April, and just last week Southwest Pacific was launched, and we will go into this in a bit more detail, so I don't need to dwell on that today. And just a snapshot here is really what's happening in Asia specifically. We'll look at Southwest Pacific again in more detail tomorrow, but we're really seeing floods and storms as the main natural hazards over the last year. But in contrast, over such a vast region as Asia, we're also seeing the extreme heat driving wildfires and droughts. So we're getting everything over a large continent, but the point here is that everything is becoming more extreme, more intense, more frequent. And this is what's happening in 2024 so far. So these sorts of features will appear in next year's report. But even in the last week, we've seen a super typhoon impact Japan. We've seen incredibly strong rainfalls impacting Philippines and storm surge. So every week I'm seeing in this region quite a visible and extreme impact. And this is grabbing the attention of the policymakers and decision makers, but it's also affecting communities. And so we need to look after them as best we can. One thing I'd like you to remember is that it's been very clearly established by the Global Commission on Adaptation that a 24-hour warning in advance of a natural hazard will reduce the damage and the impact by 30%. So this is really the key message in terms of the effectiveness of early warning system. And not only does it save lives and protect livelihoods, it also saves billions of dollars annually. So it is a very worthy investment. And I also want to illustrate with an example of anticipatory action. By using early warning systems, by getting the message to the people who need it the most and can have the most impact to save lives, this is the approach that we should take. Tropical Cyclone Mocha in 2023 developed in the Bay of Bengal, and days in advance of it making landfall, the regional specialised meteorological centre in India sent the information to the humanitarian agencies, to the World Food Programme, and action was taken in advance of impact to evacuate people to safer places, to also enable them with advanced financing so that they could get through the disaster and out the other side with lower impact. And importantly, only a few hundred people lost their lives, whereas 50 years ago, a similar intensity cyclone, Bola, impacted the same region with the same intensity and hundreds of thousands of lives were lost. So this is a very clear story in terms of the success of early warning systems. I'm going to skip through some slides in the interest of time, but just to highlight that there are many financial mechanisms already in place. I mentioned CRUISE and SOF, there's also Green Climate Fund, Adaptation Fund, and we can talk a bit more about those later. And as a slide to really finish, I want to illustrate the importance of working in partnership. This initiative is for all of us, but it can only happen with all of us, and we need to collaborate. So I've mentioned the pillars, I've mentioned SCAP, but you can see on the left-hand side, there are many more, not just UN agencies, but non-government organisations, regional organisations and bilateral partners who are contributing to this, and we need to harness this and leverage this opportunity. We can't do this alone, we must work together. And a logo I'd like to see on my next time I deliver this presentation would be ASEAN, because I think the ASEAN Secretariat is ready to coordinate, mobilise and support this for the ASEAN members. I'm not going to commit to anything right now, but I think we need to have this discussion, how ASEAN can work together to make this initiative a success in this region. And just to finish, honouring my time commitment, Early Warnings for All sits at the middle of the Sustainable Development Goals. It contributes very clearly to each and every one of the 17 Sustainable Development Goals, not just climate action, but the work that the National Meteorological and Hydrological Services do to support sectors such as health, agriculture, transport, the list goes on. All of these are contributing to Sustainable Development Goals. Now, climate change and global warming is holding Sustainable Development Goals back, which is why I commend to you that you need to support even more strongly the National Meteorological Hydrological Services to do the valuable work they do so that we can get SDGs back on track and progress, and not just in this region, but globally. And with that, distinguished guests, ladies and gentlemen, I will leave with this slide. It is absolutely clear to me, and I hope now to all of you, that early warning systems do work. But we need your support so that they can work for everyone. Thank you very much for your attention. I hope you enjoy your lunch, and I look forward to talking with you. Thank you. And if there are any questions or comments, perhaps we have 1 or 2 minutes spare.
Do we have any questions for the floor? We have time for just one question. In that case, in the interest of time, thank you, Mr. Churchill. May I invite you now down from stage?
Thank you very much.